physics point. So, student, in this lecture, my dear, I'll discuss uh, like previously what I taught, my dear. Basically, electrostatics force means Coulomb's law in air medium. Yesterday, student, I taught you student, electricity due to finite length of current. Electricity to what? Finite charged wire, right? Like semi-infinite, infinite, or finite length. Now, students, in today's lecture, I'll discuss majorly that is remaining portion of electric field. You can say like electric field on the axis of ring, electric field on the axis of disk, uh, and I can say problem based on this. So that is, I can say, major agenda for today class. Okay, so have a look, my dear everyone. Now I'm going to start the class anytime, anywhere, student. You can watch any lecture, right? Students, I'll upload all live stream lecture on YouTube as it is. I'll upload lecture, I can say entire lecture on YouTube, my dear, as it is, so that you can feel comfortable and you can learn the physics easily everywhere. So, my dear, I can say, what's the topic, Peter? This is, I can say, student, I'll not derive all result. I'll give you result only, right? I'll do few numerical based on this. So, my dear, what's the topic here? This is student electric field, student electric field on the beta axis of ring. What was it? Electric field on the axis of ring. Yes, beta. This is, I can say, beta topics here. This is student. I can say first topic is student. My dear, this is the first topic of today class, right? Okay. So beta, I can say after this, should I'll not keep. I can say entire beta derivation and all, right? I'll keep it a straightforward formula, my dear. So have a look at it. Yeah, you can say student. This is what the ring uniformly charged ring. This is bit I can say top view of the ring, my dear. This is what, my dear, top view of the ring. Okay, students. So this is what, my dear. It's a uniformly charged everywhere. Students, it's a uniformly charged everywhere, right? Okay. And better I can say this is students' side view. What, my dear? This is better the top view of the ring. This is top view of the students' ring. This is what, my dear, side view. This is what, my dear, side view, which is also kinetic beta. So, what is students? For just I'll give you little bit of basic point. Students, you can take this is element here, right? So now we will take the same element over here because this is top view, this is side view. Students, you can take, my dear, R is what? Radius. Students, you can take R is what? Radius. What's the question, student? Electric field on the axis of ring. What, my dear? Electric field on the axis of ring. Okay. Now it has a student, R is what? Radius of ring. Beta R is what? Radius of the ring. Right. Okay. Uh, Now, Bachari, I can say for next beta Z. What's the thing beta which you can remember? Let us suppose you have to use student little. I'll discuss vectors only, right? So due to this element beta, you can take what? This is what? Directions of, okay, it's a small element beta. So you can see what? This is what, my dear, electric field, which is equals to D, which is equals to beta D. Now beta, let us suppose you can say this is theta, this is what theta. This beta I wanted to expression, right? That is what needs electric field beta. You can take beta component d cos theta beta. This is d sin theta. So we can say, bacha, this is what electric field in this direction. This is I can say for D horizontal component student, that is what is this directions. Now beta I can see this is element. Let us suppose just beta take for consideration, my dear. This is D beta, this is the element DLR. So due to this element beta, what you can say? You can say this is what D. So now beta D cos theta, this is D sin theta. You can see beta D sin theta cancel each other. Right, my dear? Okay, so finally, beta will get a result. What's beta, my dear? Hello, Aryan beta, how are you, my dear? Okay, so finally, beta will get result beta on this axis. This one I'm not going to derive entire result because I'll do the advanced questions from there. So electric field beta, what is electric field on the axis of wind, my dear? This is we can write beta. Okay, very good beta, Aryan beta. I'm very happy to see, my dear. This is what's this one electric field on the axis of wind. No, beta, this is repeat. If you will understand over here, if you are understanding the topic over here, because this is same repeat telecast in magnetism as well. So it is the maximum topic repeat telecast of electro one in magnetism, like properties of electric field in electrostatic beta or electro one. You can say same kinds of properties, some similar and some you can say unlike and dissimilar beta for magnetism as well. So beta, I can say these two are very close concept. So you can see beta, this is K, Q, X, beta. This is X distance from center. This is center beta. This is X beta. Formula K, Q, X. Upon beta, you can say this is R square plus X square to the power beta 3 by 2. This is what you can say beta electric field. Okay, got it, Bacha Bati? Okay, no, Bacha. This beta, one thing I wanted to discuss with that is I can say beta mathematics. Let us suppose, student, you can put over there x is equals to 0. You can say, sir, electric field remains 0. If it agrees, you can say x is equals to 0. So beta ji, what you can say? Electric field is equals to 0. Now beta ji, here you can see here, x is equals to infinity. Beta again you can see here, electric field is what, my dear? 0. Okay, beta both of it is electric field 0. So we can tell, sir, somewhere electric field will maxima or minima. Somewhere beta you can say, sir, electric field maxima minima. Yes, you are correct, my dear. Right. Beta for maxima or minima, I hope all of you remember. Student, for maxima or beta you can say minima. What would you differentiate any function? So beta just this differentiate this electric field with respect to x, my dear. Right. So this is k qx upon beta z r square plus x square to the power 3 by 2 upon dx. So student, if we will differentiate beta, then you will get here x is equals to plus minus r by root 2. As I said here, I'll not derive any result, right? But I'll say everything. So beta here you can plot beta graph e versus x, my dear. Students, here you can plot graph beta e versus x, right? So beta here you can say beta. This is what electric field is minimum beta c minus r by root 2. Maximum beta is what you can say plus r by root 2. Electrical beta minimum बच्चा जी minus r by root 2 beta, and here बच्चा what you can say plus r by root 2. Simple बच्चा बाटी. Okay, they can also ask what is the electric field maxima. So beta I can fit simply बच्चा x is equals to what बच्चा जी plus r by root 2, right? So बच्चा once here you can calculate बच्चा बाटी, because already beta J means ask here multiple time बच्चा straightforward result will be beta z. So students, for electric field beta z maximum, beta I can say what x is equals to plus r by root 2. So bacha I can fit over there bacha k q x. What my dear? This is k q and x is what beta r by root 2. This is beta r square plus beta x is what r by root 2 near. So you can say r square by 2 to the power beta 3 by 2. Simple, yeah. So beta, this is what you can say r square common you can take here. So r cube cancel कैसे beta? So what you will get finally बचा what is this is 2k cube by beta जी 3 root 3 r square. So keep in mind बचा party electric field maximum या 2k cube 3 root 3 r square बचा party. So theory beta I can say finished. Student theory या theory point beta already I finished here, right? Now on the beta party I'm going to start here advanced numerical. Beta keep in your mind beta result here it's highly required. The students keep in your mind beta. The student keep in your mind here this all result electric field on the axis of ring. This is beta first result electric field on the axis of ring beta. Then they can ask what is the maximum minimum beta. This is what plus minus r by root 2. Once you'll fit the value of x plus r by root 2 beta, you will get electrical maximum 2kq 3 root 3 r square beta. So this beta keep in your mind, my dear. Okay, beta have a look beta numerical here. Students have a look beta the numerical. It's not tough, it's a simple here. Mathematics only. Yes, beta. So beta I can say what's the questions? Hmm. Beta you can take uh what you need to find. Yes, you can do beta for myself directly here. Calculate students calculate time period of oscillation. What was the time period of oscillation here? Uh, yes, beta. Remaining thing, beta, just I'm going to show beta in figure here. Figure shown. Yes, bacha ji. So beta, you can see here for this condition. This is a ring beta, which is uniformly charged. It's a good question here. But beta, patiently you have to try beta ji. This is you can say ring, which is uniformly charged. What is the frequency which is uniformly charged? Now, students, you can take R. R is what? Radius. Students, you can take from center of ring to beta any finite distance beta z. Now, yeah, I'm placing a charge particle, which is what? Charge q beta z mass m, right? Beta, you need to find a time period of accession. Student, you need to find time period of accession. Beta, Adin, can you answer me, my dear? Are you a student? Can you answer me, my dear? Anyone from all of you? Okay. I'm looking. There is one candidate. Maybe Aryan is there. So Aryan, can you answer me this question? Okay, wait. Now I'm going to solve there. Calculate time period of oscillation. Simple, yeah. Yesterday, student, I said a little basic point about us. I can say time period of oscillation. So this is what I can say. Let's say for solution, I'm going to start with Jazzy. Beta, what is the minimum condition here for a system? F directly proportional to beta c minus x. Beta, this is the first condition. Right, beta? Okay. Then yeah, what about time period? This is, you can say, bacha, 2 pi root under m by k. 2 pi beta what? Root under m by k. So now, students, I'm going to start a solution of the question. This is, my dear, I can say step 1. What was your party? I'll use a simple formula of electric field definition beta. Already I said in the classroom. F is equals to beta Z minus QE. Right, beta? Here already we know. E beta already we know here. You can take beta as a distance from center to here, beta, so that we can apply the formula. X. This is what my dear. You can say beta just simply X here. Okay. Then beta, I'll use the formula beta. F is equals to minus QE. What is electric field beta? Just now I said here. Electric field is what? KQX. upon beta g r square plus x square to the power 3 by 2. So student, you can write here f is equals to minus q and e बच्चा पार्टी k qx upon beta g r square plus x square 3 by 2. But I know, but there's little displacement here. So we can say, bacha, x is what much less than r. So but I can ignore beta this point over here. So f beta minus k capital Q small q into x. Upon beta is what we can say r cube. Simple here. Now beta result already proved. This is students minimum requirement for SSM bacha, which I already proved. Right. So what's the beta time period here? This is 2 pi under root m by k. So k is what beta? This entire terms here. So finally, students, you can write answer here for this question. What beta? T is equals to 2 pi m beta. This is beta you can say m beta party and k is what? K small q into beta is r q. So student, this is answer beta for this question. Yes, beta. This is answer beta for this question. And literally, students, this kind of numerical you have to make a grip. This will help you a lot. Anytime, anywhere, you can watch physics one lecture. You can watch anywhere, anytime. Physics one lecture, bacha. In detailed solution, I'll upload as usual same on YouTube, bacha. Okay, now beta. I hope beta take a screenshot here. I'm giving you 5 seconds. Yes, beta. Then beta, I'll start bacha, next numerical here. Okay, I can say iron is not there. Yes, beta. Next question, beta ji. So what's the question, beta? Find, beta. These all are I can say standard question, beta. Literally, beta. Very standard question. Find interaction, beta ji. Find interaction force between ring and semi infinite uniformly charged, beta. Semi infinite uniformly charged wire. What the uniformly charged wire? Beta, it's a good question, beta. Okay, someone asked me this question. Beta, what's the question, beta party? Try to understand here. Beta, this is you can see ring. This is what you can say, beta, the ring, right? Now, beta, you can say here for this condition, R is the radius. What my dear? R is the radius, right? Okay. Now let's just what says beta. This is what semi-infinite. What beta find interesting for sweeping ring and semi-infinite uniform charge wire. You can take beta. This is semi-infinite charge wire. This is what my dear. This is basically semi-infinite charge wire. Okay, fine. So what is the basics one beta for this question, my dear? Beta, God bless you for reaction student. Okay. अच्छा जी, simple beta, very simple solutions here. I can say this is initial diagram, bacha. In same diagram, beta, my dear student, I'm going to explaining here. Bacha, God bless you for reaction, my dear. Okay. Now, students, for linear variation here, beta for rod and ring, what we have to take lambda, my dear. So here, students, I can say you have to move by students, you have to move by and beta z take element dy. You have to move by beta and what take element dy. Right, beta. This is students, I can say minimum condition. You have to move by and beta what you can say take element dy. right, beta? Okay, so beta, if you have taken with a small element, so students, you have to find, that's God bless you for the exam here. Students, you have to find elemental charge. What student? You have to find, this is elemental charge. This is nothing but dqs. So dq, what it is, my dear? Lambda into dy. I hope you remember here. Otherwise, I'm feeling which lambda is what? This is which are the charge per unit length. Lambda is what, which you can say charge per unit length. So dq beta, what you can write? dq is equals to lambda into dy. dq is equals to what, which lambda into dy. Okay, now beta z, we wish to find beta what? Interaction force. So beta first I'll find electric field here. So I can say beta, this is beta, I can say in step one. You can easily understand my dear. In step two beta. Now I'm going to find beta force for a small element here. So this is what, my dear, you can say df. So df is what beta? You can say this is dq. This is dq into what was that party? dq into E. So dq beta already I found here. This is lambda into dy. Electric field bacha, we remember here. Electric field on the axis of ring. Just now I said bacha. So beta I'll use beta same result here. This is what k q beta z by formula what beta? Electric field on the axis of ring k q x upon beta z r square plus x square. So this is what beta k q by upon beta, this is k q by upon beta r square plus x square to the power 3 by 2. Right, beta buddy? Okay. Now beta, beta, this is expression of beta for small element. But we wish to find beta on this, I can say uniformly charged semi-infinite wire. Due to this beta, I can say what? Ring complete force bacha party. To getting beta answer F bacha. Beta, this we have to apply beta what? Concept of integration, my dear. Right? So bacha, just do beta. This is what? Integration of df. Integration of df bacha. Beta, constant term beta few. You can take it out here. This is what? K q lambda bacha. Integration of by into dy upon beta g r square. This is my dear by square. I said by square, but I wrote beta wrongly here. R square by square. Right with separate. Now, students, we can say this is what beta g 3 by 2. Beta here little change in beta, which I'll apply with separate over here. What with separate? Here, student, let us suppose I'm considering beta. Let us suppose, student, here I'm considering r square plus by a square is equals to t square. The integrate differentiate beta both side, yeah, not integration student. Differentiate beta both side beta. So r remains 0 beta. So this is beta, any constant term differentiation will be 0. Beta by a square. What you can write beta party by a square 2 by d by 2 d dt beta. 2 cancel here. So you can write, my dear, by dy is equals to beta d dt by dy. What will the party? T into dt. Okay. So beta, I'll apply beta same thing over here, beta. So what I can say by dy beta, beta. What is initial limit here? What is the initial limit was party? This is what 0 to infinite. What was the party? 0 to infinite. Initial बच्चा ना 0 beta up to infinite here. Okay, but beta you will take consideration here. Then beta time of limit also will be changed. Time limit beta what you can say also will be changed. Initially बच्चा let us suppose beta by is what 0. By is what बच्चा party 0. So beta this is I can say the individual discussion here for limit. How to take limit because initially 0 to infinity bacha. Now what we are considering assumption r square plus y square is equals to my dear t square. So here bachcha what you can say beta g for this condition students for limit here I'm considering r is equals to uh, beta this is you can say bachcha initially there is no value of y beta if you are telling for limit bachcha this is what y is equals to 0 so you can say bachcha simply here t is equals to r. If y is equals to 0, bacha, then what we can say? T is equals to r. Okay. Now, bacha ji, you can take care next condition, bacha. What is the maximum value of y? Infinity only. Yeah. So, beta, for that condition, beta, what we can say, bacha, party? This is what, beta, time will be 0. Time, beta, what you can say? 0, yeah. Okay. So, bacha, party, what's the limit of time, bacha? For this expression 0 r to 0 here not 0 to r to 0 beta take snapshot my dear I wanted to turn the page yes beta so student already I wrote expression of beta df only what is to df expression this is k beta what's the expression of df you can say k q Amicha, this is chaji k q lambda integration with the party 0 to infinite here. This is by dy. What my dear? By dy upon beta is the r square plus x square to the power 3 by 2. As I said, my dear, r square plus x square is equals to t square. And by d by what beta we can see? T into dt. So this is beta df you can write here. K q lambda limit beta what? R to 0. By d by beta you can see here t dt. Beta just go and watch which previous 16 video lecture t into dt. Upon beta this is r square plus x square. Yeah, already I said. I'll write here once r square plus x square beta t square. So beta this is what you can see r square plus x square is what cube square r square plus x square t square. So this is what I can say. This is what basically entire and this is what you can see beta is r square plus x square which is party t cube here because this is what we have taken t square which is party right. Means I'm writing x everywhere, but you can keep your mind here. This is r square plus y square is equals to t square, right? What's about t? So finally, beta, you can say, in terms of t beta, I can write beta for us here. This is t q beta g, right? So beta, you will take here df force k q lambda beta r to 0. This is g dt upon beta. This is what gq. Beta, you can see here, this is cancel. So beta, finally here you can write df k q lambda. This is dt upon t square. Now beta, we can integrate here further. R to 0 beta. So df beta force only. K q lambda beta. This is what? Minus 1 by t. R to 0 beta. Apply limit, upper limit minus lower limit beta. So force beta, what will get here? This is k q lambda by r. What is the force bacha will get here? K Q lambda by R. So student, this is answer beta ji for this question. Student, this is the answer for this question beta. So as I said here, basically session design beta ji, I can say for advanced candidate. Means can also be I can say can watch the video, but majorly beta it's a calculative section my dear. Majorly students I can say it's a calculative section my dear. Okay beta ji, have a look next questions here. Beta, same question means pattern of electric. What is the maximum pattern of question beta? I can say electric field on the axis of ring beta. Find electric field at point B figure shown. Beta G, what's the questions you can think? Find find electric field. Find electric field at point P, बच्चा जी figure from. Yes, beta. So बच्चा, what's the thing, बच्चा? You can understand easily here. Beta, you can take this is the ring, बच्चा. This is what uniformly charged, right? We wish to find beta what electric field. Uh, since we can take normal consideration, R is what radius, right? Beta, you can see beta at any distance x, at beta the any distance x, at beta the any distance x from what center of the ring, bachcha. You can say this is what point P. You can say bachcha, this is what basically point P. Okay. Beta ring is what? It's beta negatively charged. Students, you can say ring beta what? Uniformly charged, which is negative bachcha party. So here bachcha, we used to find electric field bachcha at point P. So simple beta, we can say here, it's a negative charge bachcha. I hope all of you remember formula of electric field. This is K Q X. Upon bachcha body, this is R square plus X square 3 by 2. This is beta, I can say formula of electric field. This is what, my dear, formula of electric field. K Q X upon beta R square plus X square power 3 by 2. It's negative bachcha. It's what negative here. So electric field due to negative charge ring bachcha at point P. What we can say beta in this direction here. So what is the direction bachcha party? Towards the center. This electric field direction, students. What we can see? Bachcha negative here. So this is towards the center bachcha. Towards the center, my dear. Okay, fine. Electric field at point P due to plus Q charge. Beta, you can take both consideration. Beta, what we have taken with the party minus Q charge. So this is what towards the center. That if we are taking here, I can say electric field at point P due to plus Q charge. Then beta, what we can say with the party? What we can say with the party? This is you can tell, my dear. This is step one. In step two, bachcha, I'm considering electric field, electric field at point P, at point P. This is due to beta plus Q charge, plus Q charge, bachcha. So simple beta, I can apply formula. Electric field beta is due to point charge K Q by X square. What bachcha ji? K Q by X square. Beta, we wish to find electric field net here at point P. Electric field net at point P, bachcha. This is K Q by X square minus beta G. K Q X upon beta. Simple here. This is R square plus X square 3 by 2, bachcha. So beta, further just solve here everything. KQ by X square, bachcha. So finally you can take, my dear, this is a question. So it's a kind of good question here. In today class, I'll do students only good questions so that you will get confidence. So that beta, you will get confidence here. Now, bachcha ji, yes, beta, I'm turning the page, beta. You can take snapshot, my dear. Okay, okay. Come, bachcha ji. Next question, beta. What's my dear? Next questions here. Student for next question. Find force on rod due to the. So, beta, which I'm questions, which I'm doing question, my dear. These all are super standard questions, bachcha party. So we can say find force, find force on rod. Find force on rod due to the find force on rod due to ring beta z. Okay, this is the question here. Beta, I can write here. This is what figure shown. बच्चा जी figure shown बच्चा. What's the question, my dear? You can take my dear. This is students. I can say ring. This is you can take beta ring, right? I can see beta on the axis of ring. Student, there is what one rod is placed. Student, one rod is placed. Okay. Now students, I can say this is ring bacha, which is you can take my dear for consideration. It's plus q charge. Ring bacha you can say this is what positively charged beta. Student, the ring is beta positively charged. Okay, right. This is rod beta. Rod beta you can take here. This is lambda coulomb per meter. Uh, Student, you can take in consideration beta. This is R is what? Radius of ring beta Z. Right. Now students, you can take my dear. This is what? L is what beta? L is beta Z. This is length of rod. No, beta, I can say in the I can say lecture one or two beta in of electrostatics. Already I said how can we do how can we find electric field or force on a rod, right? Because this is the, I can say standard beta process here. This is student very standard procedure here. So for solution student, I'll make here one more diagram so that you can easily understand. This is beta. You can take ring here. This is a ring beta, and this is what my dear radius are on the axis of ring beta. Students, on the axis of ring beta, there is what one rod is placed. Rod beta length you can take beta as LR, already mentioned in the questions. Now beta, what is the procedure? Beta, this is students plus charge everywhere uniformly beta. For rod, I hope all of you remember lambda coulomb per meter. No beta, what is the procedure here for this question? Very simple beta. You have to move x. What is to it? You have to move x and take element dx. You have to move x and take element dx beta z. Right, beta. If you have taken element beta z. Hello student, how are you, my dear? What's your name? From where are you? No, beta. Please tell me your name, beta. From where are you? And from where you are watching the video? State, city, district, country. No ignorance, Micha. Please write your queries, Micha. I'll answer you, Micha. Basically, I was solving question, my dear. No ignorance, beta, at all, yeah. So now, beta, you can say, Micha. This is what, my dear. This is you can see dx. Since we have to move x, beta, and this is what you can say, Bacha ji, dx, right? So, beta, no, I have taken beta elemental. I can see beta element on a rod, Bacha. Maharashtra. Okay, I post my doubt. Scroll above, sir. What is your doubt? I didn't get beta any doubt, bacha. No, bacha, I didn't get any doubt. Beta, please post once more time, beta. Yes, beta, please. Beta, we have to move x, and beta, we take element dx, right? Okay, so beta, this is beta. I can see due to small element, bacha. You need to find elemental charge, bacha, right? So, student, elemental charge. And this is what, my dear? Elemental charge, right? So this is dq bacha. Okay, class 11th. mm, 11th will finish before 30th May 2026. Self-studying from the channel. students for 16:30. Okay. Uh, good student. Good beta. So what you wanted, beta? From my side, my dear. Student, may I know your name, please? And what you wanted, beta, from my side? This is beta for DQ charge, beta for small element. This is what beta lambda into dx. What, my dear? Lambda into dx, right, beta? Okay. So we wish to find here what force. So beta for small element, beta, you have to write here small force. Beta. This is df. This is nothing but beta. This is dq into dq beta already found here. Electrical on the axis of ring beta we know everyone. So this is beta df here. I can say k q into beta k q x into dx into lambda here. Don't forget lambda upon beta is what we can say r square plus x square 3 by 2 is beta z. Again beta, what's the initial limit here? Beta, this take beta entire terms constant, my dear. So this is students, you can say df k q lambda into beta g 0 to L near entire limit beta 0 to L beta. This is beta, I can say x dx upon r square plus x square 3 by 2. Now let's say, okay, students here, yeah, beta, this is beta, I can say concept of 12th class mathematics beta. Okay, uh, beta, if really beta, if student, if really wanted beta J advanced good rank, student, if you really wanted a student J advanced good rank, then beta you have to manage beta J. At least beta J 75% beta you have to do multiple correct beta. Single correct beta it's fine. But if you literally wanted beta, I can see good rank in JEE advanced. So beta you have to do student. So Vitaji, you have to do, my dear. Okay. So now, students, here I'm considering Vitaji few assumption Vitaji. What, my dear? Just yeah, already underlined. So just keep in your mind. I want under 5K NC advanced. Then you have to follow physics point. Then you have to first follow physics point and numerical. Physics one, I can say especially numerical live session. Very, very helpful for you. If you have a really very good knowledge of oscillation, you can come and join tomorrow evening, 7 o'clock, oscillation class. Right? You can compare your content which you learned from somewhere and what I'll avail you. You can make a comparison. Then you can easily understand what's how much you need extra more numerical to do for your rank which you wanted. R square plus beta. Here I'm considering beta R square plus X square, which is equals to my dear T square, right? So beta R remains constant here. X is a variable beta. So beta just two beta differentiation both of the side. Beta I can say I started a student many batch, right? I wanted to give you beta something, right? Beta, you can anytime beta, anywhere. You can contact at physics point beta, right? Beta, this is the landline number beta. This is I can say WhatsApp number, right? If you wanted more informations about batch or beta here, all kinds of batches also available like online classes, individual classes, compliance of syllabus. They means they advanced session one, finished already sessions two, everything is started beta. So, according to your suitability, beta, you can contact here, beta. right? For more information, bacha, I'll help you, beta ji. Definitely, I'll help you, bacha, as per your expectation only, beta. I hope you have taken, I can say, screenshot of this information. Okay, fine, bacha. So beta ji, have to bacha ji. R square plus x square is equals to bacha t square. Now, beta, just differentiate bacha ji. Mohit, beta, both side. Your name is Aniket. Na, yes, your name is Aniket, beta. Aniket, beta, just beta, differentiate both side, bacha, party. Beta, differentiation of any constant term, Aniket, zero, bacha. Beta, x square, what you can write, bacha? This is what? 2x into dx. T square, beta, see, this is 2t into dt. 2, beta, I can say finish here. So I can say x dx is equals to t dt. Students, x dx is equals to t dt. Right, beta? I would like numerical for class 11 advanced illustration solving from class 11 starting 20. Ah, yes, sir. I'm telling you lecture. You can go, students, you can go and beta, already beta I uploaded many lectures on fluid statics. Beta, there are segment, bacha, fluid statics with, I can say concept come numerical. Beta, I can say few lectures already I uploaded there. They're only numerical, right? So, Aniket, just once, beta, you can just visit the channel, or if you will not get it, beta, just you have to WhatsApp. I'll help you with that. Yes, beta, I can say, beta, you can say newly I just started Aniket, right? So, beta, I uploaded beta lecture on statics only. Fluid static beta, I beta uploaded all the lecture like Archimedes principle, buoyancy, pressure variation, all categories, accelerated fluid. So, beta, you will go and watch beta channel of Physics Point, right? You will just try to bit of find the things like accelerated fluid by physics one BK sir, Archimedes principle, buoyancy force, pressure variation. Beta, you will get all lecture over there, student. Yes, beta, you will get all lecture of fluid static, bacha body. Yes, definitely you will get, my dear. So now, beta, x ds beta, what you can say TDT. Now, students, if you are beta taking consideration Aniket like this, bacha, then beta for this condition, just beta change your assumption here. What you can say here, if x is equals to 0, so what beta? You can say 3 is equals to r. If beta, you can say x is equals to l. So 3 is equals to root of beta. You can say r square plus l square. Yes, beta g. X is equals to L beta g, so you can see T is equals to root of R square plus L square. This is the condition vector, right? Now beta, I can say beta, this thing beta, I'll feed over here. So this is, I can say beta, this is df force, K Q lambda. X dx beta g, you can say this is what? T dt beta, this is TQ here. This is TQ beta. Limit beta I can apply beta. So initial limit what? R. Initial limit, student, you can apply, my dear. This is R. But the final limit is what, beta ji? This is R square plus L square. But I'll write here once more on next page. Yes, beta. So what is df, beta ji? Beta ji, expression of df. What I wrote, beta? I'll write from here only. This is K cube lambda, beta ji. R to beta g, this is R square plus L square beta 3 dt upon tq. 3 dt upon beta, what we can see tq. Dt cancel beta g. So this beta integrate both sides beta party. So this is students df. You can write my dear. This is k q lambda beta R to students. You can say R square plus L square. This is beta, you can say dt by t. This is what beta you can see dt by no, this is dt by t square here. Cancel it dt by t square. I hope all of you remember yesterday already I said dx upon beta x square minus 1 by x, which are integration here. So df beta becomes f beta. This is k q lambda into beta. This is minus 1 by t r into root of r squared plus l squared, r squared plus l squared. Now it's yeah. So finally we take it right here. F is equals to beta minus take it out here. So we can see k q lambda into 1 upon r minus let's say g 1 upon r squared plus l squared. Yes, yes, beta. So this is I can say beta questions of beta. I can say answer of this question. This is the question here. Once have a look beta. Here people find force on rod D to ring. So this is beta uniformly charged ring here. I can say rod has a length L, lambda coulomb per meter. So beta we have to find force on what? I can say beta rod. So this is force beta body K Q lambda 1 upon R minus 1 upon R square plus L square. Beta this is answer beta for this question. Yes, beta ji. After this beta we have to do more question beta ji. Beta we have to do more questions here. No beta as I said here it's a advanced section beta for physics here. It's a beta ji advanced section beta for physics here. Right. So beta find electric field at center figure. What is the questions my dear? Find student find electric find electric field at center figure shown. What picture party? Figure shown. Right. Okay. Uh, now picture. Have a look here. Sorry, sorry. Means what's the diagram for questions diagram? Beta. You can say picture. This is beta. You have a semicircular plane. This is because you have a semicircular plane. What you can say R is a radius. You can take beta lambda coulomb per meter. Now, okay. You can take beta. This is center point O. So we have to find beta electric field at what center. Now, beta, this is a very common process. Beta, I can say, student. This is a student very common process. Beta, you can just keep in your mind. If you have a rod and ring, so what's the charge you have to take? Students in electrostatics, you can take what's the lambda coulomb per meter. Same methodology, same concept, beta, you can apply to find center of mass of a rod in beta center of mass and beta to find moment of inertia of a rod in rotation. Same concept, beta, you can apply over there, bacha. What bacha is? You have to move x. Beta here x for rod here. It's a ring bacha. So what you can take, beta, you have to move theta. Beta, I'll go slow here. It's highly important, my dear. You have to move theta. What my student? You have to for a ring bacha. You have to move theta. Take element d theta. Yes, beta. This is highly required here. You have to move theta and take element d theta. Now, students, you have to write what is this arc length. Beta, to getting arc length, which I can apply formula here. What is theta? Theta is students. I hope all of you remember arc length upon which is radius. So simply, which I can write here arc length. This is theta into radius. So this is बच्चा जी arc length. What's the theta, बच्चा? This is d theta into r. Yes, beta. This is arc length there. So we wish to find what's the charge over there, beta, because we have taken element, my dear. So we can say this is dq is equals to lambda r d theta, beta. I'll teach literally very slow so that we can understand at physics point each and everyone equal. Anywhere, anytime, you can watch any video in detail. So, beta, what I said, this is the dq charge, beta. What element only, bacha? Elemental charge, you can see lambda r d theta. What we wish to find, beta? Electric field. You can tell, beta, very easily. Sir, electric field, beta, we wish to find over here. It's what light charges due to point charge, bacha. Beta, I wanted to make, beta, one more diagram. I wanted to make, bacha, one more diagram. This is, you can see, bacha. This is, students, you can say dq. This is what you can say, bacha ji, theta. So beta due to this here, you can write, my dear, this is what de. What beta ji? You can write, my dear, this is what d. So this is theta beta. You can say from alternate angle. This is remains theta beta ji. So this is, you can say, d cos theta. And what, students, d e बच्चा जी sin theta. D cos theta beta. And what I can say, this is D sin theta. Okay. Now, students, I'll beta treat these two beta. I can say individually. Students, here first I'll find beta EX. Students, EX, what you can write beta G? EX, you can write beta. This is D E cos theta. E by beta, what you can write? E by, you can say this is DE sin theta, right? Whichever D. Okay. Then beta, this beta takes snapshot beta. I want you to turn the page, my dear. Okay. So beta here, I'll calculate individually beta EX and EY. What, my dear? EX and EY. So EX is what beta? EX is what? D E cos theta. EY, what, my dear? This is, you can say, DE sin theta. Okay, fine, bacha. So, beta, what is the condition here? DE, beta, we have to find. Beta, we have to find D. Beta, I'll find D, beta, here only, right? D, beta, I'll find, my dear, here only. So, DE is what, bacha? K DQ by R square. So this is बच्चा जी K and dq beta lambda r d theta upon r square cancel बच्चा जी. So beta de I can say K lambda into beta d theta by r. K lambda d theta by r बच्चा. K lambda d theta by r बच्चा, right? This is d. So I can say बच्चा party this is what beta K, what is d बच्चा party? K lambda d theta by r. You can write beta K lambda by r into beta. This is cos theta d theta. Okay, so this is what limit beta from where to where apply bacha? 0 to 180 degree. What bacha party? 0 to 180 degree bacha. Just simply beta, just integrate here. So what's the limit beta? 0 to pi because it's a semicircle beta. So you can say beta this is ex bacha party. You can take beta K lambda by r common. Limit beta 0 to pi r. This is cos theta g theta. What's the integration cos by party sign here? Keep in mind, don't say negative sign. So electric field x which k lambda by r. This is what sine theta 0 to pi. I hope all of you know sine n pi is what 0. So electric field beta Ex is equals to what you can write? 0, my dear. Okay. Then बच्चा party will go next year. E by बच्चा. So what is E by beta जी? This is integration of d sin theta. Beta d already be found here. K lambda by r into cos theta बच्चा. So we can write beta as usual. K lambda by r integration 0 to pi. बच्चा जी, what beta? This is sin here. Don't write cos. This is what, my dear? This is, my dear, sine. Yes, beta. This is beta ji sine theta d theta. What beta ji? Sine theta d theta. Okay. So sine integration beta minus cos here. Beta, keep in mind here. This integration differentiation both are opposite to each other, beta ji. So E by what beta you can say? K lambda by R. Sine is what? Minus cos theta 0 to pi. So this is what you can see E by बच्चा पार्टी. This is K lambda by R minus बच्चा. This is cos pi minus cos 0. So simply बच्चा I can say E by beta K lambda by R minus beta, what we can say? Cos pi beta minus beta outside. Cos pi beta minus 1. Cos 0 beta g, what we can say? 1 only beta. So minus beta what? Minus 2 minus outside beta. So you will get here electrical by beta 2 k lambda by r. What is we can say? 2 k lambda by r, right? So beta I can say this much here only for today class. Right, beta. This much I can say we have a little thing here which I wanted to complete here for arc. I wanted to complete with chapters. Yes. So what is next, bacha? Next, beta, I can say electrically due to quartering. These all are beta. I can say problem. I can say concept. Also, we are helping concept building student. So this is student electric electric field due to quartering. Electric field due to quartering. Right. Bacha, I can say electric field due to quartering. Bacha. So as I said here, for information, what's the charge beta? Lambda coulomb per meter. What was the party? Lambda coulomb per meter. Okay, a ring beta, beta same approach you can apply, my dear. You have to move theta. Student, you have to move theta, and student, you can take element d theta. You have to move theta and take element d theta. This is r d theta. This is what would say the r d theta. Now you can say beta, this is what? DE. Same thing you can beta treat here. This is students, you have a DQ charge. So due to this DQ charge beta, this is the electric field, right? Bacha? This is theta here. You can say this is what remains theta. So this is what beta you can say remains theta. This is nothing but here. This is DE. Beta take element here. So you can say this is DE cos theta beta, and this is you can tell my dear d e sin theta, right beta ji? Okay, now beta ji, again beta we can take here ex and e by beta. What you can take ex and e by beta. Yes, I'll beta solve here, my dear, individually. So beta, this is ex, no need to take beta direction beta, right? So ex is what beta? DE cos theta. Beta, we have to find which is DE over here. So how can we get DE bacha? Simple beta ji. DQ can Okay, dq beta first, right? dq is what? Lambda r d theta bacha. So what about dq bacha? D. For finding d bacha, I'm using here electric field due to point charge k dq by r square. So beta I can fit value over here dq beta, which already we calculated. So d bacha what you can say? K lambda d theta upon r. Yes, beta. This is d bacha. K lambda d theta upon r. So this is beta. I can say ex. D bacha party k lambda upon r into beta g cos theta d theta. Limit you can apply, my dear. This is what 0 to beta pi by 2. Simple, yeah. 0 to pi by 2. Cos integration, don't forget beta. It's a sin theta only. Don't forget, bacha. It's a sin theta my own, dear only. Ex here. K lambda by r. Cos theta is what beta we can say? This is sin theta, 0 to pi by 2. So ex beta what we can write here? Ex is what? K lambda by r. Now beta, you can say this is what E by d is sin theta. D beta already we calculated, my dear, over here. So this is what? E by bacha ji. D beta how much? K lambda by r sin theta d theta. Limit you can apply, my dear. 0 to pi by 2. So beta, you can see this is E by K lambda by R. K lambda by R. Sin theta beta, what you can say? This is what? Cos theta. Just keep in mind is minus cos here. Minus cos theta which here. So E by, you can do it, right beta? K lambda by R minus beta, I can take it out which here. Cos of I by 2 minus beta G. Cos of 0. I hope all of you remember. Otherwise, I'm telling beta, this is 0, this is 1 beta, minus minus plus. So student, you will get here E by also beta, K lambda by R. Right, beta G. Now you can say, beta, you have electric field in x-axis also and in y-axis also. So beta, you have to find net electric field here. You know, this is the basically property of electric field lines here. Electric field lines beta always give you what? Net electric field beta. So beta, I will get what is net electric field here? Because this is what you can say beta, what is x-axis. This is x-axis beta. How much, my dear? K lambda by R. Beta, one more bacha party. This is what bacha? K lambda by R. So what you will get, my dear? This is student root 2 K lambda by R. Yeah. So what's answer, my dear, for this question here? Yes, beta. Directly remember. Yes, you can apply beta G. You can apply, my dear. Very good. But I'm going to just discuss beta those one only which you already said, bacha. So this is 2 root 2 beta root 2 k lambda by r beta. For I can say electric due to quartering bacha. What answer? Root 2 k lambda by r. Yes, beta. That is beta more useful bacha. Beta, which you said bacha, that is literally very very useful here. So I'm calling bacha, that is the last point for electric field. Beta, this is electric field student, electric field at general point of circular arc. Yes, beta. This is literally very, very useful, beta. Beta, if you remember this one, yeah, then you can beta, calculate all formulas with respect to ring, right? Or beta arc, circular arc. Let us suppose when I'm considering a circular arc, right? So this is what you can say radius of this circular arc. The arc here, so what you can take, this is student charge lambda coulomb per meter. This is the radius r beta, this is radius r. Okay, now students, I can say beta, same point beta, you can apply for ring here. Students, you have to move theta. Student, you have to move theta and take element d theta. You have to move theta, take element d theta. Due to this element, student, you can see this is what electric field. This is what beta, you can see electric field. So this is theta here. This is theta, bacha ji. So what you can say, this angle is what? Also theta. This is bacha ji, you can see d due to small element, my dear. This is what beta, you can see d cos theta. This is what student d sin theta. Okay, that one more thing, bacha party. What you can say, beta ji, this is here. Let us suppose you have taken an element this side. So this is what d. This is d cos theta. This is d sin theta. Student, let us suppose if you will consider beta element this side, bacha. So this is d. So what we can say, d cos theta and d sin theta. So beta, you can take beta what due to symmetry, d is sin theta what cancelling each other. Beta, what you can say, cancelling each other, bacha. So electric field net, bacha, what you can say along beta d cos theta. So you can write, my dear, electric field net is equals to, this is dE cos theta. So dE beta, what we can write here? Due to beta point charge. dE beta is due to elemental charge. Or beta, here I'm going to use your electric field formula due to point charge. What, my dear? dE is equals to K, beta, here, K dQ by R square. Beta, dQ is what, my dear? dQ is what, my dear? This is lambda r d theta. Lambda r d theta, bacha. But I can apply, bacha, but d. So you can say k lambda d theta by r. What, bacha ji? K lambda d theta by r. Okay. Now, bacha, just apply the limit here. We'll get the answer from here, bacha. D already found here. So students can write here electric field net. D, bacha party. K lambda. This is beta d theta cos theta upon r. Limit beta ji minus alpha by 2 to alpha by 2. So students, here you can write electric field need, bacha party. K lambda by r beta minus alpha by 2 to alpha by 2. Beta, you know how limit here. Beta, you know this entire angle beta mentioned in the question there. This entire angle beta, student, this is entire angle beta mentioned in the question, student, which is nothing but you can say, bacha ji, this is what alpha. This is what it is, alpha. So you can take beta, this angle is what? Alpha by 2. This angle is what? That means this is, you can take beta origin here. So this side beta, what you can see? Minus alpha by 2 beta. This side, what you can see beta? Plus alpha by 2 beta. So this is beta, you can say cos theta d theta, right? Bacha ji, finally you can just solve electric field need, bacha party. K lambda by r cos integration, bacha, you can see as sin theta. So this is, my dear, you can write sin theta minus alpha by 2 to alpha by 2. So we can write beta finally here upper limit minus lower limit k lambda by r sine of beta alpha by 2 upper limit beta minus, beta, you can tell which as the minus sine alpha by 2 beta. If you remember here, I can say vomiting concept, right beta? Vomiting concept here, vomiting concept, right beta? What's the vomiting concept here? Beta, I can say we have a six functions: sine, cos, tan, cot, sec, and cosec. Beta, I can say cause and sec. After food, they will not do vomiting, right? But remaining beta can do vomiting, right? So beta due to this beta, sine beta will what? Beta this sign. This beta what? Minus sine alpha by 2 will beta come outside. So finally beta you can write electrifinate at any point of general point of circular armature. This is you can say K lambda by R. The students, literally, it's a highly important, bacha, right? Anytime, anywhere, you can come, you can visit, you can just put queries on YouTube, just put the lecture name. You will get with the entire derivation student as well. K lambda by R, bacha. This is 2 sine alpha by 2. Yes, beta. Already I can say Manish. Manish, yes, you said beta. Good. Good, beta. You should already answer this question. And literally, beta, it's very, very helpful. Yeah, it's beta. I can say very, very, very helpful, beta. Party. How beta? Just take a little. I can say application of this formula. Beta, little. But I can take a application of this formula, beta. Let us suppose. Beta, let us students consider semicircle. Beta, what we can say this is what semicircle. So, beta, electric failure already we calculated for semicircle. Beta, how much? 2 calendar by year. Just beta, just feed value over there, bacha. I can say EX. Beta, what is the electric field we got here? Finally, formula bacha. Now 2 K lambda by R into beta sine alpha by 2. So alpha beta what we can write? This is 180 near for semi circle bacha. 180 bacha. Beta feed over there. So we will get bacha what? 2K lambda by R. Sine 91 bacha. Sine 90. What you can say, bacha? 1 year. But you can take, bacha. This is a quarter circle. Or beta, you can say quarter circle, you can say, bacha, or you can say ring, bacha. Right? So, bacha, what is elliptical, bacha? This is 2K lambda by R. And this is what? Sine, bacha, party 45 degree. 1 by root 2 here. So, finally, beta, just apply concept of rationalization. You will get bacha electric field what root 2 K lambda by R, right? So like this I can derive all the result. So student, this is all about beta. I can say this live session. Tomorrow beta, as usual beta, I'll come and discuss remaining part of electrostatic. Now students, all the very best everyone. I'm very happy to see till now we're staying in live session at this point. You're most welcome forever beta. Now I'm going to stop live session with party. Beta, God bless you, Manish. Okay, Manish, beta, I wanted to share you beta one thing. Beta, Manish, you can take beta anytime, beta. Manish, beta, anytime, beta. If you have any queries, you can beta call on landline, beta. WhatsApp number is there. Yes, good night, Manish. Manish, beta, just take beta detail contact detail of this one, beta. Manish, beta, from where are you, beta? From where are you watching videos of streaming it? Like say, from where are you, beta? Okay, very good, very good. Manish, beta, I have taken contact detail of this point. Okay, I hope you have taken beta. Manish, okay, fine. Now, bacha, I'm going to beta. Okay, good. Yes, beta, you can anytime, beta, you can contact beta for your queries. Beta, most welcome forever, beta. All kinds of tuition available over here, beta. I can say syllabus compliance fastly means advanced, beta, online one-to-one system, beta, available, beta. All the very best, Manish. I'm very happy to see my dear.